So we have a graph and we want to go through 3 different concepts. The first one is interpolation, and that's going to be predicting within a graph. And that means within the data points. So it means within data points. So if I look at my graph, I'm going to look for my highest data point, my lowest data point, and kind of boxing these in. So anything in this range would be within my data points. This top line probably should have been over just a little bit more. And then, so for example, I can ask a question such as, if I got 25, I think these are seconds, on Monday's race, what would I predict to get on Tuesday's race? Because when I go there, whatever I get, it's going to be within this box. It's within my data points. I have data points surrounding it. It tends to be more accurate, whatever our predictions are in there. I could say, Tuesday's race was 60 seconds. What would you predict Monday's race would be? And again, when I get my answer using my graph, it's going to be within my data points. My next one is extrapolation. And that is predicting outside of my data points. And then the further from our points, the less accurate. We just don't have any examples around there. And that could be on either end. So, for example, I could talk about things that are under 5 seconds. That would definitely be an extrapolation because I don't have any data points around there. So saying if I got a 3 on Monday's race, what would you predict would happen on Tuesday's race? That would be extrapolation. More often than not, it's going the other direction. So maybe I'm going to say you got 100 on Monday's race. What would you predict would happen on Tuesday's race? I couldn't use the graph, but I'd be able to use my equation because most likely we would have written an equation. And again, the further we get from our data points, because we don't have any actual points around there, our accuracy just goes down. For example, 10 years ago, if we predicted cell phone usage or landline usage, we would not have made a good prediction because at that point, nobody was assuming that people would be getting rid of their landlines, because why would you get rid of something that's such an integral part of life? So we don't know what's going to happen 10, 20 years from now. Nobody could have predicted the things that are happening in this year 5 years ago for 2020, just because, a lot of things changed and happened with coronavirus. So that would be a way that extrapolation isn't as accurate, but it's predicting where I don't have any data points, and we would say outside. And again, that's kind of going either to the smaller end or to the larger end, and our accuracy isn't quite as high. The last one that we haven't gone over is correlation coefficient. And so we're going to just kind of hit the basics of this. There's actually calculations that would calculate, and it's really calculating how far each number is off the line. So the first thing is going to be positive, negative, or none. If you can draw a line, it's either positive or negative. A none would be a graph that looks more like this, where we just have points almost in a block. There's absolutely no way I could draw on a line. A positive would have a positive slope, because as x increases, y also increases. So this particular graph has a positive correlation. A negative would have a negative slope, because as x increases, your y value decreases. And then, like I said, none would be one where we wouldn't have a line on there. So you wouldn't see that on a test, because I want you to draw on a line and then talking about the correlation coefficient. The second is just, are points close to line or far away? So are points close to the line or far away? Because that would be what we would be calculating. And we would just look at a particular number with that, but we're just going to make a statement. Our accuracy is going to be increased the closer the points are to the line. So if I look at this one, our line would be pretty accurate So it's a positive correlation, and it's pretty accurate. Oh, can't spell that. Pretty accurate since the points are close to the line. If we had a graph that had a few extra points on there, that maybe they were out here and down here, we would say that our line isn't as accurate just because our points are more spread out. And what correlation coefficient would do is almost put in a bolder line, and we start looking at saying, every time we'd have a prediction, we'd have to add so much to it or so much less from it, and we're not actually doing that calculation. So yours are just positive, negative, or none. If you put none on the test, that means you didn't draw a line, and that means you got a ton wrong, so don't use none. And then describing how close our points are to the line. And that would be all the pieces that we have left.